Hi folks, welcome to the BEA BR3 Programmable 3 Relay Logic Module, Pull Cord Inhibit, Delayed Activations, and Other Alternative Uses webinar. Hopefully at the top of your screen you see a red spotlight. We will use that to guide through the presentation. Stand by, we'll get started. BR3 Relay Logic Module Objectives: Programming the BR3, explaining wet versus dry output of Relay 1, explaining functionality of timers on the BR3, using the BR3 to inhibit a pull cord, using the BR3 to delay an activation, using the BR3 in a reverse logic mode, using multiple BR3s to accomplish different things. Here's a picture of the BR3. Here we have the inputs, then we have the outputs or the relays, power here. We have programmable jumpers for wet output, dry output, AC or DC, and then 2 setup and adjustment buttons. Universal Service Module. Service contracts require maintaining many different brands of doors and a lot of special requests for unusual applications. Many times, these special requests can be accomplished using the BR3 or multiple BR3s if you just think out of the box a little bit. Specifications: 12 to 24 VAC, VDC, current draw 30 to 130 milliamps. Temperature range -15 to 150 degrees. Inputs, dry 1 to 4, different inputs. Wet input 1 rated at 5 to 24 VAC or VDC. Outputs, dry contact rating relay 1 and 2 is 3 amps. Relay 3 is 1 amp. When selecting wet output, relay 1 is the only wet output option. It's rated at 1 amp. In lieu of 3 when it's dry. Dimensions: 5.2 inches wide, 2.2 inches deep, and 1 inch high or tall. ABS plastic, RoHS compliant. Summary of functions. Function 10, time delay relay. 11, ratchet or latching relay. 21, approach sensor inhibit with door position input. 25, 2 relay sequence, and that's the function we'll be discussing most of it today. 22, sequence with approach sensor inhibit. 28, 2 relay sequence with door position input. 29, 2 relay sequence with relay 1 deactivation timer. 35, 3 relay sequence. 50, interlock timer with door position inputs. 55, interlock ratchet with door position inputs. 65, 2-way bidirectional 2 relay sequence. This is the only function we can control relays independently. 75, 2 relay sequence. Programming. The module must be programmed to work. If you do not program it, you got nothing. First, program to the function needed for the application. In this example, function 10, 25, or 35, and this will be displayed on the BR3 7-segment display. Second, program a value to all applicable H timers. If an H timer is left at 00, the relay will not trigger. H1, or it could be H2 or H3, that's the hold time for that respective relay, must have a value more than 0. Third, program any applicable D1 or D2 timers. If the D1 or D2 timers are left at 00, all relays of the selected function will trigger simultaneously. D equals delay. Programming. 1. Press and hold both push buttons, INCR and PAR-AM, increase in parameter buttons for 3 seconds. The display will toggle between FF and 00. Number 2, press the INCR button to toggle through each function. A display of 10 corresponds to function 10, 11 to function 11, etc. Number 3, wait approximately 10 seconds for the display to stabilize and show the given function, 25 here. Press the param button to cycle through the function parameters. As each parameter is displayed, press the INCR to increase or change its value. Number 4, press the param button to move to the next parameter. If for some reason you see an NP on the display, when selecting a new function, as the display toggles between FF and 00, if you accidentally press the param button, first the display will show NP for no parameter or not programmed. Wait 5 to 7 seconds, start again, and cycle through the functions using the INCR key. Here's a programming example. Press both buttons for 3 seconds. You'll see FF00 alternate on the display. Press the INCR button and cycle to 25. Press that button repeatedly until 25 shows on the display, and then wait for about 10 seconds to let it stabilize. Next, press the param to cycle to H1. Next, press the INCR till 03 is shown for H1, 3 seconds. And then next, press the param to cycle to H2, and then press the INCR till 01 is shown for 1 second. Next, press the param to cycle to D1, and then next press the INCR till _2 is shown. That's 0.5 or 1/2 second delay. And 9, wait for the 5 seconds for the display to go inactive and shows a constant 25. You're done. Wet versus dry output of Relay 1. Jumpers, by default, the BR3 Relay 1 or R1 is set to a dry output. Here we've got these 2 jumpers, covers up DC. If we move them closer to the module, cover up these 4, you would have AC as your wet output. But nothing would happen if you didn't change these 2 jumpers from dry to wet. By default, this jumper's covered, this jumper's covered, and it's dry. Move it over here and here for wet, and then here and here for wet. Before doing this, you must power down the module, otherwise you'll let the smoke out. Additionally, you may select the wet output as DC or AC wet. This is dependent on the BR3 source voltage. Source voltage to AC or DC output, DC source voltage to DC output only. So Relay 1 can have it wet or voltage output. Whatever the source voltage is, that is the approximate voltage that will be output on Relay 1 when you select wet. So we can rectify AC voltage and have wet DC voltage output on Relay 1. We cannot invert that. Wet versus dry output of Relay 1. When using Relay 1 as a wet DC output, the common number 1 terminal will be positive side of the DC, and normally open and normally closed, I should say normally open or normally closed, will be your negative side of the DC. When using Relay 1 as a dry output, you will need an external power source for the item connected to Relay 1. This could be a light or buzzer. Functionality of BR3 timers. Relay 1 always energizes immediately when the input is activated or shorted. Relays 2 and or 3 can be delayed after an input has been activated or shorted. The relays will remain energized as long as the given input is maintained. Functionality of BR3 timers. For multi-relay sequences, the delay timers, D1 or D2, run when the given input is activated or shorted. Here, showing these timers, what you would see on the 7-segment display of the BR3. For hold timers, H1, H2, H3, the timers will not start until after the activation input has been released or unshorted. H1, 2, and 3 corresponds to relay output, relay 1 or R1, relay 2, relay 3. Functionality of BR3 timers continued. In this example, function 25, a 2-relay sequence, H1 timer or hold time for relay 1 is set to 0.5, 5 seconds. Hold time for relay 1. H2 equals 10. Hold time for relay 2. D1 set to 0.5 is the delay time between relay 1 and relay 2. So relay 2 would not fire, or would fire 5 seconds after relay 1 fires. Functionality of BR3 timers continued. Input 1 is activated or shorted. Relay 1 energizes immediately, R1. 5 seconds later, relay 2 energizes because D1 is set to 0.5, and both stay energized until input 1 is released or unshorted. Then 5 seconds later, relay 1 is de-energized or relaxes, and H1 equals 5 seconds, and 5 seconds after that, 10 seconds total, relay 2 is de-energizes because H2, the hold time for relay 2, is set to 10. Using the BR3 to inhibit a pull cord and activate a warning light. In this scenario, we have a pedestrian walkway in front of a high-speed door with a vehicle traffic that uses a pull cord to activate the door. Using the BR3 to inhibit a pull cord and activate a warning light, the customer wants a push plate that pedestrians will push before walking across in front of the door. Here it looks like we've got some travel lanes for forklifts. This would be our door area, and we have a walk lane or walking aisle for pedestrians. When the push plate is pushed, the warning light will turn on and the pull cords will be inhibited for the time set on H1 and H2 respectively. So a pedestrian here or a pedestrian here presses the push plate, will start the BR3 sequence on the timers to inhibit or take out pull cord so that a forklift cannot pull the door open and possibly run over a pedestrian. There's a wiring diagram we'll explain. As you can see, in this scenario, we have used function 25, the 2-relay sequence with relay 1 set as a wet DC output. So we configure our BR3 to a 25, and we set our jumpers to wet DC output. Continuing along, all push plates will be paralleled into input 1, IN1, and ground here. So if you had 2, 3, 4, 5, 6 push plates, they would all be paralleled into this input, and this will be used to start the sequence. Push plates could be replaced by any dry contact device such as safety beams. When a pedestrian walks through the beam, the light would turn on and the pull cords would be disabled until the time expired. So the only thing different in this application is the person doesn't have to press a push plate, they just pass through and it automatically starts that sequence. This is the same wiring diagram. Using our DC LED light, it's being powered directly from the BR3 Relay 1, common and normally open, because we've got Relay 1 configured as wet DC output, and we're using the common and normally open to power DC LED light. For pull cord inhibit function, one wire from each pull cord must be connected in parallel to the activation input of the door control. Here in this example, we've shown two pull cords, so one wire of each pull cord here is routed to the activation circuit. Continuing along, the other wire from each pull cord will be connected in parallel to the common terminal of Relay 2 of the BR3. The normally closed terminal of Relay 2 will be connected to the common or input of the door control. Here, showing connected, and the other side of the Relay 2 routed to the common of the door control. Here's what happens with this diagram. When the push plate is pushed, Relay 1 will activate the light. Then Relay 2 will open, inhibiting the pull cords, and it will stay this way until the timers H1 and H2 expire. So set your jumpers on the BR3 to wet. If a beacon light or LED light is DC powered, set the BR3 jumpers to DC. Set the H1 timer to 10. This will be the time the beacon stays on. Note the time can be set to anything from 0:1 to 60 seconds. Next, set the H2 to 10. This will be how long the pull cords will be inhibited or disabled, and this can be set from 0:1 to 60 seconds. Make sure you leave the D1 timer set to 00. This will cause the beacon light and the pull cords to be inhibited simultaneously. So the beacon light comes on and the pull cords would be inhibited at the same time. I don't think you'd want to have a delay to inhibit the pull cords 5 seconds after the beacon light comes on. You could if you wanted to, though. Here's another application. In this warehouse application, we have a busy travel lane where fork trucks travel past the door, which only requires a limited amount of traffic traveling through the door. So we have heavy traffic coming this direction. We have intermittent or much less traffic coming into the doorway. We don't want this heavy traffic activating the door here. Therefore, we only want the door to open when a fork truck sits on the ground loop or under the presence sensor for a given amount of time, thus allowing fork trucks to pass through the travel lane without opening the door. So again, traveling back and forth through here, we don't want to activate the door. So a fork truck comes in and it must sit here for a set amount of time that you configure the BR3 to trigger the door, which we'll see very soon. So configure the BR3 to function 25, but this time use Relay 1 as a dry output via the jumpers, and that is a default setting. You won't have to change any jumpers, and then we'll leave Relay 1 as a dry output. Next, using a BEA presence sensor such as the I30 or IS40, and you can wire normally open those sensors, either of those sensors wired normally open to input 1 and ground, the activation that starts the sequence for the BR3. Relays 1 and 2 are wired normally open in series to the activation of the door control. R1, or Relay 1, normally open to the door control activation. R1 common to R2, normally open. R2 common to the door control activation. So I'll repeat that since it's in series. R1 normally open, routed to the door control here. And then R1 common goes to R2 normally open, and then R2 common to the door control activation, shown here. Set the BR3 to function 25. Set the timers as follows. H1 equals 1 second, H2 equals 1 second, D1 equals the presence time required before activation occurs. If the presence detection is lost on input 1 and ground before the D1 timer expires, the door will not activate. So here we have a presence sensor going routed to the input 1 and ground. Whatever we set D1 to, let's say 10 seconds. If a presence sensor is in detection for 9 seconds, nothing will happen. The door will not open. But if the presence sensor is here for 10 seconds or more, then and only then the BR3 through this series wiring will trigger the door to activate. So a vehicle would have to be in detection for 10 or more seconds for the door to activate, or whatever time you program D1 to. When a presence sensor detects input 1 is shorted, relay 1 fires, closes, and the D1 time begins to run. If the presence sensor loses detection before D1 expires, R1 will open, preventing the closure of R2 from activating the door. If detection remains for the time set in D1, R2 fires, closes, and the door is activated, just like we said on the previous slide. Keep in mind, some of the other functions the BR3 are capable of. Function 35 is a 3-relay sequence. Function 50 can prevent one function from occurring until another is completed. Function 65 is the only function where we can either run a relay sequence, reverse the relay sequence, or control the relays independently. That's it. If you have any questions, please contact BEA Technical Support. Contact information is below. Technical support, sales, customer service, one number, 800-523-2462. For general technical questions to all of BEA Tech Service, we have a general email box, tech_services@beainc.com. We also have information on our website, beasensors.com. If you have any questions, stand by. We'll bring you back online. Thanks for attending.